Hello, and welcome to Astronomy Daily, the podcast that brings you the universe, one day at a time. I'm Avery.
And I'm Anna. Today we're covering everything from an update to a spacecraft anomaly at Mars to potential signs of primordial dinosaur stars.
That's right. We'll also be looking at a successful private spacecraft rendezvous, our visiting interstellar comet, the dazzling Gemini meteor shower, and the future of asteroid mining. So let's get started.
First up, an update on some concerning news from the Red Planet. NASA's MAVEN spacecraft, which has been studying the Martian atmosphere since 2014, has gone silent, as we reported late last week.
Yeah, this is a tough one. The mission team reported losing connection on the 6th, and so far they haven't been able to reestablish a connection.
What's the leading theory on what happened?
Well, they did receive a very brief signal on the 6th, and an analysis of that signal suggests the spacecraft was rotating unexpectedly. That could mean its orbit has changed, which would explain the communication loss.
And MAVEN isn't just a science orbiter. It's also a crucial communication relay for the rovers on the surface, right?
Exactly. The good news is that NASA is already mitigating the impact. They're rerouting communications through their other 3 orbiters at Mars, the Mars Reconnaissance Orbiter, Mars Odyssey, and ESA's ExoMars Trace Gas Orbiter.
So Perseverance and Curiosity can continue their work?
That's the plan. The rover teams have had to adjust their daily planning, but the missions are continuing. Still, it's a significant loss if MAVEN can't be recovered.
It's worth reminding our listeners just how important MAVEN's primary mission has been. It stands for Mars Atmosphere and Volatile Evolution. Its entire purpose was to figure out how Mars lost its once thick atmosphere and abundant water.
That's right. It carried a suite of instruments to study the upper atmosphere, the ionosphere, and its interactions with the solar wind. It's thanks to MAVEN that we have a much clearer picture of Mars's climate history and its transition from a potentially habitable world to the cold, dry planet we see today.
So the loss of MAVEN isn't just an operational setback for the rovers. It's a scientific one, too. Let's hope the team can work some magic and get it back online. The data it provides is invaluable.
That's right. We're keeping our fingers crossed for the mission team.
From a mission in trouble to a mission demonstrating incredible new capabilities, 2 private companies, Starfish Space and Impulse Space, have successfully performed a surprise rendezvous in Earth orbit.
This is a really cool story. It's part of a mission called Remora. Essentially, an orbital transfer vehicle from Impulse Space named Mira used autonomous software developed by Starfish to approach a second Mira spacecraft.
How close did they get?
Within 4,100 feet, or about 1,250 meters. What's amazing is that this was a 9-month project from conception to execution. The second Mira launched in January 2025 and met up with the first one, which had been in orbit since November 2023.
That's incredibly fast for a space mission, and this kind of autonomous rendezvous is a critical step for future satellite servicing, right? Things like refueling, repairs, or even deorbiting space junk.
Absolutely. This isn't Starfish's first success either. They had another mission, Otter Pup 1, that maneuvered close to a different space tug back in April 2024. They are really proving out the technology for a new era of in-space logistics.
Next up, as you probably know by now, we have a special visitor from outside our solar system. The Interstellar Comet 3I Atlas is set to make its closest approach to Earth on December 19th. That's this coming Friday.
This is only the 3rd confirmed interstellar object we've ever detected, after Oumuamua and Borisov. It's a really rare event.
And when we say closest approach, we should clarify it's passing at a very safe distance.
Oh, absolutely. About 1.8 astronomical units away. That's around 168 million miles. So no need to worry, but it's close enough for our telescopes to get a fantastic look.
And that's the real prize here, isn't it? The chance to study its composition and learn about the materials that make up other star systems.
Observatories like the Hubble Space Telescope and even ESA's JUICE probe, which is on its way to Jupiter, have already been observing it. For everyone at home, the Virtual Telescope Project will be hosting a free live stream, so you can see this interstellar visitor for yourself.
Put it in your diary. This is one of those opportunities that doesn't come around too often.
All right, let's go from visitors from other stars to the stars themselves, the very first ones. Anna, this next story about the James Webb Space Telescope is mind-bending.
It really is. JWST may have found the first evidence of what some are calling dinosaur stars. These aren't just big, they are truly colossal stars from the very early universe, with masses potentially up to 10,000 times that of our own sun.
10,000 times? That's almost impossible to imagine. How would a star like that even exist?
Well, the theory is they would have lived very short, incredibly brilliant lives before collapsing directly into massive black holes. And this could be the missing piece of a major puzzle in cosmology.
You mean how supermassive black holes got so big so fast in the early cosmos?
Exactly. These dinosaur stars would provide the perfect seeds. The evidence comes from a galaxy named GS 3073, which has a very unusual chemical signature, specifically a strange nitrogen to oxygen ratio.
Right, and that signature matches the theoretical models of what these supermassive primordial stars would produce. They'd get so hot they could fuse carbon and hydrogen together, creating enormous amounts of nitrogen that later enriched the galaxy. It's an incredible find by Webb.
And this discovery opens up a whole new field of study. If these dinosaur stars were common in the early universe, it would fundamentally change our models of galaxy formation. It suggests that the first galaxies were seeded with massive black holes almost immediately.
It also raises new questions. For instance, what were the conditions that allowed stars to grow to such unimaginable sizes? The early universe was a very different place, mostly hydrogen and helium, without the heavier elements that help cool gas clouds and limit star size today.
So the next step for astronomers will be to hunt for more galaxies with this unique chemical fingerprint. If they can find a population of them, it would move this from a fascinating possibility to a cornerstone of early universe cosmology. It's a testament to Webb's power that we can even ask these questions.
And yet another great example of the JWST's value to us here on Earth.
Okay, bringing our focus back closer to home, skywatchers were treated to a phenomenal display over the past week. The Geminid meteor shower peaked on December 13th, and it was truly spectacular.
I saw some of the photos coming in online, and they were breathtaking. The Geminids are always one of the best showers of the year, known for their bright, fast meteors.
And they're interesting because they don't come from a comet. The debris that creates the meteors is from an asteroid named 3200 Phaethon.
That's right. Astrophotographers captured some stunning images from all over the world. There are shots from Yosemite National Park, from across China and Germany, showing these bright streaks of light against familiar constellations like Gemini, Taurus, and Orion. It's a beautiful reminder of the celestial mechanics happening all around us. And speaking of asteroids, our final story looks at their potential, not as a source of meteor showers, but as a source of resources for future space exploration. We're talking about asteroid mining.
This has been a staple of science fiction for decades, but a recent study suggests that small asteroids could be the key to making missions to the Moon and Mars more sustainable.
So what kind of materials are we looking for?
The researchers focused on a type called carbonaceous chondrites. These are fragile asteroids, rich in carbon, organic compounds, and potentially valuable metals. Most importantly, many contain water ice.
And water is the gold of space exploration. You can use it for life support, and you can split it into hydrogen and oxygen for rocket fuel.
Precisely. Now, we should be clear that the technology for large-scale extraction is still a long way off. The loose, gravelly surface of these asteroids, the regolith, presents a lot of engineering challenges.
But the potential is huge. It's not just about fuel and resources. Studying these asteroids up close could also help us understand and figure out how to mitigate any potentially hazardous asteroids that might threaten Earth. It's a technology with dual benefits.
It's a fascinating prospect, but beyond the engineering challenges of actually grabbing onto and processing these loose piles of rubble, there's also the economic and legal side of things. The 1967 Outer Space Treaty is a bit ambiguous on the ownership of space resources.
That's a key point. Countries like the United States and Luxembourg have passed national laws recognizing the right of private companies to own resources they extract. But there isn't a global consensus yet. It's a new frontier, not just technologically, but legally as well.
And economically, the initial investment is astronomical, no pun intended. The business case relies on creating a self-sustaining in-space economy. You're not bringing these materials back to Earth. You're using them to build and fuel operations in space, making everything cheaper in the long run.
It's the ultimate long-term investment. But with companies like Astroforge and Transastra already developing technologies and planning missions, it feels like we're on the cusp of this science fiction concept becoming a reality. It will be exciting to see how it unfolds over the next decade.
And that's all the time we have for today. From a still, silent orbiter at Mars to the promise of mining asteroids, it's been another busy day in space and astronomy news.
Thanks for tuning in to Astronomy Daily. We'll be back tomorrow with another roundup of the latest from our amazing universe. Until then, I'm Avery.
And I'm Anna. Keep looking up.